Hello guys, welcome to my YouTube channel Anil Physics Academy. In today's video, I am going to discuss about vector product or cross product of two vectors. In my earlier lectures, I discussed about dot product of two vectors. So there are two types of multiplication of vectors. First is dot product, which we have discussed earlier, and in today's video we will discuss about cross product or vector product of two vectors. See, here are two vectors, vector A and vector B. Theta is the angle between vector A and vector B. So the cross product or vector product of the vector A and vector B is denoted by vector A cross vector B. And remember that the vector product or cross product of two vectors is a vector quantity. As we had seen in the earlier lecture, that dot product of two vectors is a scalar quantity, but the vector product or cross product of two vectors is a vector physical quantity. So and as we know, a vector product of a vector physical quantity has two things. It has magnitude and direction. So the vector product of two vectors, vector A and vector B, has both the things. It has magnitude and it has direction also. So what is the magnitude of vector A cross vector B? Its magnitude is given as magnitude of vector A into magnitude of vector B into sine theta. This is the magnitude of vector A cross vector B, that is the cross product of vector A and vector B. Now, what is the direction of vector A cross vector B? See, the direction of vector A cross vector B is perpendicular to the plane in which vector A and vector B lie. Here, vector A and vector B are in the plane of this board. So, the direction of vector A cross vector B is perpendicular to this board. But there is a little confusion. There are two perpendiculars perpendicular to the board. One is out of the board and another is into the board. So how can we decide whether which of the perpendicular is the direction of this vector A cross vector B? To avoid this confusion, we use a rule which is called right hand thumb rule. By the use of right hand thumb rule, we determine the direction of the cross product of two vectors. So for this, we have to find the direction of vector A cross vector B. So we align our four fingers along vector A and curl them towards vector B. Then the direction of thumb gives the direction of vector A cross vector B. Here we can see my thumb is pointing outward the board. Yani my thumb is coming out of the board. So the direction of vector A cross B is in a perpendicular to the board and coming out of the board. So we can write the direction, denote the direction a unit vector n cap, where n cap is unit vector perpendicular to the board and coming out of it. Now what is B cross A? Now we will find vector B cross A. See, the magnitude of B cross A is also BA sine theta. We can also write it AB sine theta. Now what is the direction of vector B cross vector A? For this we use the right hand thumb rule. We align four of my fingers, these fingers, along vector B and curl them towards A. Then the direction of my thumb gives the direction of vector B cross A. You can see that when I align these four fingers along B and curl them towards A, then my thumb points into the board. So the direction of vector B cross A is perpendicular to the plane of the board and going into the board. That is, it is minus n cap, because n cap is a unit vector perpendicular to the board and coming out of it. So minus n cap has the direction opposite that of the n cap. So that is going into the board and perpendicular to the board. So we can write it as minus AB sin theta n cap. So we can see that vector A cross B is not equal to vector B cross A. They have same magnitude but opposite directions. So we can say that the cross product of two vectors is not commutative. But in the case of dot product of vectors, we had seen that the dot product of two vectors is commutative. That is, we had seen that vector A dot vector B is equal to vector B dot vector A. But vector A cross vector B is not equal to vector B cross vector A. So the cross product of two vectors is not commutative. Let us proceed further. Now we will see that what is the cross product of a vector with itself. That is, what is vector A cross vector A. First of all, what is the angle between vector A and vector B? These are equal vectors, same vectors. So the angle between them is 0 degree. So the magnitude of vector A cross A is A into A sin 0. And sin 0 has value 0. So it can be written as 0 vector. So the cross product of two equal vectors is a 0 vector. Now we will see what is the cross product of unit vectors along Cartesian coordinate axis. This is a Cartesian coordinate axis. This is Cartesian x axis. This is y axis, and this is z axis. See, where is the z axis? One thing I will say about the z axis, that here see, z axis is perpendicular to plane containing x axis and y axis. Then here also one question arises: it is going into the board or going out of the board? Here also we will use the right hand thumb rule to determine the direction of z axis. See, I place my 4 fingers along x axis and curl them along y axis. Then the direction of thumb gives the direction of positive z axis. So the actual, we have drawn this diagram in 2-dimensional space, but in actually the z axis is like this way. This is the positive direction of z axis, that is going out of the board. X and y axis are in the board and z axis is perpendicular to the board and coming out of it. Positive direction of z axis. So the unit vector along x axis is denoted by I cap. Unit vector along y axis is denoted by j cap, and unit vector along z axis is divided by k cap. And the mutual angle between these two unit vectors is 90 degree. Now we will find what is I cap dot I cap. See, both had magnitude 1, so their magnitude is 1 cross 1, and since these are same vectors, so angle between them is 0 degree, is equal to sin 90 degree, sin 0 degree, and this is equal to a 0 vector. So the this is cross product of vector I cap and I cap. So the cross product of I cap and I cap is 0 degree. Similarly, vector j cross vector j, it is also 0 vector, and k cross k, this is also a 0 vector. Now what is vector I cap cross vector j cap? For what is the direction between I cap and j cap? It is 90 degree. So what is their magnitude? 1 into 1 and sine 90 degree. That is, and what is the direction of I cap cross j cap? here to find the direction we will use the right hand thumb rule. So I cap is in along the x direction, and I will place my all the four fingers along x axis and curl them along y axis. Then the thumb gives the direction of I cross j. This is along z axis, positive z axis. So to denote direction, we write is k cap. And see, since sin 90 has value 0, so this is k cap. So vector I cap cross j cap is equal to k cap. Now what is the vector j cap cross I cap? This j cap has magnitude 1, I cap has magnitude 1, and angle between j cap and I cap is 90 degrees, sin 90. Now what is the direction of j cap cross I cap? For this I place my forefinger along j cap and curl them along I cap this way. We can see that my thumb is pointing into the board. So the direction of j cap cross I cap is along minus z axis, that is minus k cap. Direction of j cap and I cap is minus k cap because it is coming to out to be into the board. So this is equal to minus k cap. So I cap cross j cap is not equal to j cap cross I cap. They have same magnitude but opposite direction. Similarly, what is j cap cross k cap? So the j cap has magnitude 1, k cap has magnitude 1, and the angle between them is 90 degree, sin 90 degree. And what is the direction? J cap cross k cap. For this I place my four fingers along j cap and curl them around k cap. I have told you earlier that k cap is along perpendicular to the board and coming out of it. So to find j cap and cross k cap, I point my forefinger along this way and curl them along this way. This is the direction of k cap. So this comes out to be I cap. So this is I cap. So j cap cross. So this is equal to sin 90 have value 1. So this is I cap. So j cap cross k cap is equal to I cap. Now what is k cap cross j cap? K cap cross j cap. Both has magnitude 1 and angle between them is 90 degree. To find the direction, I place my four fingers along k cap. K cap is this, I have said earlier, along this direction. K cap and j cap is in this way. So my thumb points along negative x direction. That is, so direction of this is minus I cap. So this is equal to, it has value 1. So this is equal to minus I cap. So k cap cross j cap is equal to minus I cap. Now what is k cap cross I cap? For this I point my four fingers along k cap, that is along positive direction, and I curl them along I cap. So my finger point along j cap. So this is equal to 1 into 1 sin 90 degree I cap. J cap, sorry, j cap. This is equal to j cap. Now what is I cap cross k cap? For this the magnitude is 1 sin 90, and direction for direction I place my finger along I cap and curl them around k cap. That is this is perpendicular to, so k cap, that is, this is I cap and k cap is along this direction. So this comes out to be minus j cap. This is minus j cap. So this is, so I cap cross k cap is equal to minus j cap. So we discussed all the cases of cross product of two vectors along Cartesian coordinate axis. Now I teach you a very easy method to remember the cross product of all three vectors. So what is the method? Arrange all the three vectors, see I cap, j cap and k cap in clockwise. See this in cyclic order. Now if I take the cross product of two unit vectors in cyclic order, suppose that I cross j in clockwise order, I cross j, then it comes out to be equal to the third vector k cap. And if I take two cross product of two unit vectors in anti-clockwise direction, that is j cap cross I cap, this is anti-clock direction, j cap cross I cap, then it comes out to be minus k cap. Similarly, j cap cross k cap is equal to I cap, and k cap cross j cap is minus I cap, and k cap cross I cap is equal to j cap, and I cap cross j cap is equal to minus j cap. So guys, that's all for today's lecture. Thank you very much.